Multi-agent systems, MAS, beginner level. Introduction. Multi-agent systems, MAS, means using multiple intelligent agents, AI programs, that work together to solve problems. Instead of one AI system doing everything, MAS uses many small AI agents that can think independently, communicate with each other, collaborate or compete, make decisions. Examples of multi-agent systems include self-driving cars coordinating on roads, robots working together in a warehouse, smart traffic systems, online trading bots, game AI, multiple characters interacting. MAS helps solve complex problems that are too difficult for a single system. It introduces important AI ideas such as distributed intelligence, communication between agents, cooperation and competition, decision-making, coordination, autonomy. What is a multi-agent system? A multi-agent system is a system made up of multiple intelligent agents that interact with each other. In simple words, MAS equals many AI agents working together or against each other to achieve goals. Each agent can observe its environment, make decisions, take actions, communicate with other agents. What is an agent? An agent is a system that can sense its environment, make decisions, act based on those decisions. Example: temperature equals 30. If temperature equals 25, print turn on fan. This simple logic acts like a basic agent. Why multi-agent systems are important? Some problems are too complex for a single system because they involve many entities, dynamic environments, real-time decisions, distributed systems, multiple goals. MAS helps by K. Breaking problems into smaller parts. K. Allowing parallel processing. K. Enabling collaboration. K. Improving scalability. K. Supporting real-world systems. Types of agents in MAS. Type of agent, description. Reactive agents respond immediately to changes. Deliberative agents plan actions based on goals. Learning agents improve over time using data. Cooperative agents work together to achieve shared goals. Competitive agents compete against each other. Agents equals AD1, task, deliver package. AD2, task, monitor traffic. AD3, task, optimize route. Each agent has its own role. Simple MAS example, Python. Agent 1 equals collect data. Agent 2 equals analyze data. Agent 3 equals make decision. Print. Agent 1, print. Agent 2, print. Agent 3. This shows different agents handling different tasks. How multi-agent systems work. Step 1. Multiple agents observe the environment. Agent 1 status equals free. Agent 2 status equals busy. Step 2. Agents communicate. Message equals task available. Print. Agent 1 sends. Message. Step 3. Agents make decisions. Task equals delivery. If task equals delivery, print assigned to available agent. Step 4. Agents act and coordinate. Agents perform actions and may adjust based on others. AI in multi-agent collaboration. Agents can work together to complete tasks. Tasks equals pickup, delivery, report. For task in tasks, print assigning task, task. AI in multi-agent competition. Agents may compete to achieve better results. Agent scores equals Agent A, 80, Agent B, 90. Winner equals max agent scores, key agent scores.get. Print best agent, winner. Multi-agent system in real-world example. Example, delivery robots. One agent picks items, another packs items, another delivers items. Robots equals picker, packer, delivery. For robot in robots. Print robot is working. Communication between agents. Agents share information. Agent 1 equals need help. Agent 2 equals on the way. Print Agent 1. Print Agent 2. Coordination in MAS. Agents coordinate to avoid conflicts. Agents equals A, B for agent in agents. Print agent, avoiding collision. Full menu-based MAS example. Def assign task. Task equals input, enter task. Print, task assigned. Def communicate. Message equals input, enter message. Print, message sent. Def choose best agent. A equals int input, agent A score. B equals int input, agent B score. If A greater than B, print, agent A selected. Else, print, agent B selected. While true, print, N1, assign task. Print 2, send message. Print 3, choose best agent. Print 4, exit. Choice equals input, enter choice. If choice equals 1, assign task. If choice equals 2, communicate. If choice equals 3, choose best agent. If choice equals 4, break. Else print invalid choice. Concepts learned from MAS. Attribute distributed systems, agent-based modeling, communication protocols, cooperation and competition, decision-making systems, real-world AI coordination, real-life analogy. MAS is like a team of workers in a company. Each worker has a role, communicates with others, works toward a goal. Together, they achieve more than one person alone. Ways to improve a MAS project. Add real-time communication, APIs sockets. Use reinforcement learning for agents. Build simulation environments. Add negotiation between agents. Implement swarm intelligence. Use game theory models. Create distributed AI systems. Build multi-robot systems. Common mistakes beginners make. Ignoring communication between agents. Ignoring conflicts. Not handling conflicts. Overcomplicating agent logic. Forgetting coordination. Where MAS is used. Multi-agent systems are used in robotics, smart grids, traffic systems, financial trading, game AI, supply chain systems, autonomous vehicles, drone coordination, smart cities, distributed computing. Simple definition. Multi-agent systems, MAS. A system where multiple intelligent agents interact, cooperate, or compete to solve problems. Final summary. Multi-agent systems allow multiple AI agents to work together, making systems. Check. More scalable, more flexible, more intelligent, better at solving complex problems. By learning MAS, beginners understand how modern AI systems operate in distributed and collaborative environments.